In this video, we will see a program for the heap sort. And in the previous video, you saw that heap sort depends upon max heap. So I will use that program related to max heap. I have already explained that program in detail in a past video. You can check that. So I will use that program of max heap. So I just make a copy. Here is that this program is to get a max heap for a given array, and I copy this program. You see, I copy this program. This program has been explained in a past video. You see, I copy and I am pasting it in a new page. Here I have pasted, but I have to make a program. I have to type a program of heap sort. Obviously, there will be modification in this program because this program relates to max heap. So see the change. You see two void functions here. One is max heapify and the other is build max heap. This build max heap is responsible to give us a max heap, and this build max heap is dependent upon this function max heapify. I have already explained this function as well in a past video. You can check that. Now the addition will be related to the heap sort, so that I take one more function here, void, and here function name will be the same, heap sort, and in it I pass two arguments. If I need more, then I will modify further. And here int, the first is int star for the array name and the second is for the array size. Now since I have declared a function named heap sort, so I have to call that function. So I call that function here. You see build max heap, I change. Build max heap will also be called because this heap sort depends upon max heap, but not here. The function build max heap will be called later. I will show you. So here it will be heap sort. It will be heap sort, and obviously there are two arguments. First array name and the second is array size. Now the elements of max heap. This statement is not relevant with this program because I have to take a program of heap sort. So here the statement will be like this. Here will be sorted elements are. Now since I have called the heap sort, you see here in the body of the main function, this is the body of main function, and inside this blue shaded area is the body of the main function, and inside this you see this heap sort. So I have called the heap sort function. Since I have called a function, so I have to define it. Obviously I defined that function here. Void, here will be the function name. Function name is heap sort, and the arguments first will be the array name, and the second will be the size. Okay, thereafter I have to define this function, and you know I take one variable I for the index, and in the previous video you saw that I sorted the element of the array using a max heap, and you know to get a max heap we use build heapify. This function build heapify gives us a max heap, so I use that function, and this is the place where I call this function build heapify, build max heap, and in this as well there are two arguments, first array name and the second is the size n. Now you know in the algorithm of heap sort we regularly interchanged the first element with the last one. First we got the max heap, thereafter we interchanged the first element, that is root node, with the last node, and this interchanging is not only once, this was many times. For that I have to run a loop, and here index I will run, I will take the value of the last index, and you know the last index obviously will be n-1, and thereafter I will be decreased because the maximum index is n-1, and it will go up to the second element. Here I greater than or equal to 1. One question may be in your mind that why it is not I greater than or equal to 0. The reason is that 0, if you take I equals to 0, this means that the root node itself, and you must remember that any array with one element is already sorted. So here there is no need to take I greater than or equal to 0. I exclude that value. So I here have taken I initial value equals to last index, and the last value corresponding to the second element, the index of second element, and here I minus minus to decrease the value of I by 1 after each run. Thereafter, the body of the for loop I here define, and here you see that first in the algorithm of the heap sort, the first step was to interchange the root node with the last one. So for that, to interchange, we take a temporary variable. Suppose it is temp. Temp will store the value of the root node, and thereafter this root node will take, sorry, here will be a node. The root node will store the value of the last node, and the value and the last node will store the value of stored in temp. So here will be temp. These three statements, C statements, these three I show you. You see, these three C statements is for the interchanging. A C statement terminate with a semicolon. So interchanging is complete. Now you should remember that in the algorithm of heap sort, when I remove the root node and I kept that element at the end, when you remove an element, then the number of nodes in the remaining heap will be one less. So accordingly, I take n equals to n minus 1. This means that the value of n will decrease by 1. After each run, it will decrease. And you remember that when you take the last element at the root node, then that heap is not a max heap. And to take the next largest element away from the heap, you have to first make it max heap. So for that, I take here max heapify function to get a max heap. But one may say that why max heapify function? You know, build max heap also can make a max heap. It is especially made to get the max heap, but running time will be more. You must remember that when you get a max heap, and if you remove the root node, then the remaining two parts are two max heaps. So there is no need to use build max heap function here. If you use, then obviously in that case as well, you will get the same output, but running time will be greater. So to get a next max heapify function is sufficient. So I use here max heapify function, but you know, in the max heapify function I had passed three arguments. So here there will be three arguments max heapify. The first argument will be the array name, the second will be the root node, because you know, this is the only one element that is at the node due to which the heap is not a max heap. So we need it to be, this index to be max heapified. So I have used here max heapify function. And here the third argument is obviously the array size. the heap size, you can say. Now our program is complete. Let us run this. It says save under a file name. So I save it in the name of HeapsortThe. Heap sort. Okay, I have saved. Now it should run. It is running. You see on the screen it says enter the size. So I take first a small size, suppose 5. So I have to take 5 elements for the array. I take 45, 90, 7, minus 6, and the last one 23. You can take any 5 integers. I now press the key enter, and you see our elements are sorted. You see, this is the output. This is the output, and you notice that these integers are in increasing order. So our program for this heap sort is working well. But I say the viewers that one should verify taking many examples. So I take one more example here. I take one more example. This time I take the array size where it says enter the size. I take 12. You can take any size. You can take 50. So I have to take 12 integers for the array. So I take 23. Randomly 12 numbers should be entered, and should be checked where this program is working well or not. Now see, here there are 12 numbers: 23, 8, 90, 78, 56, minus 5, 45, minus 5, 6, 7, 77, 98, 45, 33. Okay, 1 I count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now see the numbers. You see the sorted elements are, and you see obviously this is the smallest number, and here greater than that number, thereafter 8, and 23 is even greater than 8, and you see the numbers are in increasing order. You see 78, 90, 98. So, and let us count the numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, there are 12 numbers in increasing order. So our program, this program is working well, and now I show you the entire program once more. Now this is the first part of this program. This is the second part of this program. This is the third part of this program. This is the fourth part of this program. This is the fifth part of this program. And this is the last part of this program. So I again say that this heap sort, to understand this heap sort will be easy if you go sequentially. First, try to understand the max heapify function. Thereafter, see max heap, or the function name is build max heap. I have uploaded both the algorithm as well as the code for each max heap, whether it be max heapify function or build max heap function, and the last one is the heap sort. If you go sequentially, then obviously you will be able to understand this program. Okay, thanks.